Welcome to the channel. Have you ever increased a VM from 16 to 32 vCPUs expecting better performance, only to find the application became even slower? It sounds strange, but it happens in many enterprise environments. The reason usually isn't a lack of CPU power. It's something called NUMA. In this video, I'll explain why understanding NUMA is far more important than simply adding more CPUs, and how this knowledge can help you avoid one of the most common VMware performance mistakes. Many VMware administrators believe that adding more vCPUs will automatically improve performance, but modern servers don't work that way. If a virtual machine becomes too large, ESXi may need to spread it across multiple CPU sockets, increasing memory latency instead of improving performance. To understand why, we first need to understand how today's enterprise servers are built. This is a common real-world scenario. A SQL Server or SAP application starts running slowly, so the administrator increases the VM's CPU count. Instead of getting faster, the application becomes even slower. Storage looks healthy. The network looks fine. CPU utilization isn't high. The actual problem is often hidden inside the server's NUMA architecture. Every physical server is built from CPU sockets. Each socket contains multiple physical cores, and with hyperthreading enabled, each core provides two logical processors. But there's one important detail. Each CPU socket also has its own local memory, and that's where NUMA begins. NUMA stands for Non-Uniform Memory Access. Simply put, every CPU socket has memory directly connected to it. When a processor accesses its own memory, it's very fast. But if it needs memory from another CPU socket, the request must travel across the processor interconnect, which adds extra latency. That small delay can significantly affect applications performing millions of memory operations every second. Older systems used uniform memory access, where every processor accessed memory equally. Modern enterprise servers use NUMA, where each CPU socket has its own dedicated memory. This design improves scalability, but also makes memory location important. Local memory is always faster than remote memory. That's why VMware tries to keep CPUs and memory together whenever possible. When an ESXi host boots, it automatically detects the server's NUMA layout. It identifies every CPU socket, memory region, and NUMA node. Whenever possible, ESXi schedules a VM so that both its CPUs and memory remain inside the same NUMA node. This reduces latency and delivers the best performance. But what happens when a VM becomes too large for a single NUMA node? That's exactly what we'll explore next. Once ESXi detects the server's hardware, it automatically builds the NUMA topology. When you power on a VM, ESXi tries to place both its vCPUs and memory inside the same NUMA node. This is called memory locality. Keeping everything local reduces latency and allows the CPU to access memory much more efficiently. Think of local memory as a file stored on your own desk. You can reach it instantly. Remote memory is like walking to another office every time you need a document. It still works, but it takes longer. The same happens inside a server. If a CPU frequently accesses memory attached to another socket, application latency increases. That's why memory locality often matters more than adding extra CPUs. Now imagine your VM fits completely inside a single NUMA node. All of its vCPUs run on the same CPU socket. Its memory stays local. The scheduler has less work to do. Cache efficiency improves, and applications receive data much faster. This is the ideal scenario for most enterprise workloads. Now, let's increase that VM from 16 to 32 vCPUs. Suddenly, ESXi may have to distribute the workload across two CPU sockets. Some processors now access remote memory. Extra communication happens between sockets, increasing latency. The VM has more CPUs, but it spends more time waiting for data. That's why a larger VM isn't always a faster VM. Adding vCPUs also increases scheduling complexity. ESXi now has to find more available logical processors at the same time. If the workload spans multiple NUMA nodes, remote memory access and scheduling overhead both increase. So before increasing CPU resources, always ask yourself, is the application CPU bound, or is something else causing the bottleneck? That's a question every VMware administrator should answer first. A wide VM is simply a virtual machine that's too large to fit inside a single NUMA node. Large SQL Server databases, SAP HANA systems, Oracle workloads, and AI applications often fall into this category. Wide VMs aren't bad, they're sometimes necessary. But once a VM spans multiple NUMA nodes, understanding vNUMA becomes critical for maintaining good performance. And that's exactly what we'll cover next, along with VMware best practices and a real-world enterprise example. When a VM becomes large enough to span multiple NUMA nodes, ESXi exposes vNUMA to the guest operating system. This allows Windows or Linux to understand the virtual NUMA layout and schedule processes more intelligently. Applications like SQL Server, Oracle, and SAP HANA can then allocate memory closer to the CPUs using it, reducing unnecessary remote memory access. In short, vNUMA helps large enterprise workloads perform more efficiently. So, what are the best practices? First, right-size your virtual machines. Don't add more vCPUs unless you've confirmed that CPU is actually the bottleneck. Whenever possible, keep a VM within a single NUMA node. Monitor metrics like CPU ready, CPU utilization, and application latency. And most importantly, understand your host's hardware layout before deciding the VM size. Good performance starts with good architecture. Let's look at a real-world example. A SQL Server VM was running with 16 vCPUs. When users reported slow performance, the VM was increased to 32 vCPUs. Instead of improving, the application became slower. Why? Because the VM now spanned multiple NUMA nodes, increasing remote memory access and overall latency. After resizing the VM back to 16 vCPUs, performance improved without changing the hardware. Sometimes, smaller really is faster. If you're preparing for VMware interviews, make sure you can answer these questions. What is NUMA? What is vNUMA? When does ESXi create vNUMA? Why can adding more vCPUs reduce performance? And what's the difference between CPU ready and NUMA latency? Understanding these concepts will help you both in interviews and in real production environments. Let's quickly recap. NUMA is a core part of modern server architecture. Local memory is always faster than remote memory. Adding more vCPUs doesn't always improve performance. Right-sizing a VM is usually better than oversizing it. And the best VMware administrators optimize architecture, not just resource allocation. The next time someone says, just give the VM more CPUs, remember that performance isn't only about processor count. It's about where those CPUs run and where the memory is located. Understanding NUMA helps you build faster, more efficient VMware environments and troubleshoot performance issues with confidence. If you found this video helpful, don't forget to like, subscribe, and share it with your team. Thanks for watching, and I'll see you in the next VMware Deep Dive.